Test 6, Part 2, Passage 1. Listen to a conversation between a student and a professor. Hi, Professor Smith. Are you busy right now?
Oh, hi, James. Just give me a second. Okay, what can I do for you?
I was wondering if I could talk to you about my anthropology paper. You know, the one you assigned on ancient civilizations?
Sure, go right ahead.
Well, I chose to write about an aspect of the Harappan civilization, but now I'm thinking of changing it to some other topic because I'm having trouble finding sources.
Okay. Just how did your research go? Can you tell me exactly what happened?
I was going to write about the Harappan writing system. I found it intriguing because the traditional belief is that the Harappan civilization was literate. Archaeologists discovered clay seals with thousands of symbols. The interesting part is that scholars haven't been able to decipher those symbols.
That's an excellent topic. I'm familiar with it. And you're having trouble finding sources?
Yes. Since the decoding process is ongoing, and there hasn't actually been much progress, there isn't very much material. I did find a paper, one that says that a literate Harappan civilization is a myth, that the symbols are non-linguistic. The researcher argues that the symbols have other purposes, but they aren't for communicating meaning. So I thought, oh well, there goes the writing system theory. But then I found another paper that defends Harappan literacy. The researcher has a counter-argument for each point discussed in the first paper, so there's disagreement with how the symbols were used. And if I base my paper on theories alone, it's not going to be much of a paper. And that's all I found so far.
I realize it's not easy to find information on the subject, but I still think it would make for a very interesting read. I do hope you'll stay with it. What topic were you thinking of changing it to?
I thought that maybe I could write about their architecture instead. There's a lot of material on it, and I found the descriptions of the engineering engrossing. The Harappan people were definitely intelligent, and they had advanced ideas. You can see how systematic and precise their structural plans were. And the history of how the archaeologists excavated the site is just as fascinating. Don't you think this topic would be as interesting and challenging as the Harappan writing system?
I'd say that Harappan architecture is indeed a fine topic, and for sure you won't have a problem finding sources.
Yeah, it seems just as fun to write about as Harappan literacy, and I won't run into a brick wall with the research.
I hear what you're saying. The thing is, almost every semester I get papers from 2 or 3 students about Harappan architecture. There certainly isn't a dearth of materials on the topic, but I always encourage students to go out on a limb and let their curiosity guide them.
I get it. But like I said, there isn't much I could find about literacy except that people are still doing the research.
Well, there's nothing wrong with discussing existing research even if it isn't conclusive. Have you tried looking in anthropology journals? You might find articles that present the research in a more objective light.
I tried that already. That's where I found the conflicting research I mentioned earlier. I think it may be a lost cause.
I wouldn't go that far. Research doesn't always produce results right away. It's the thrill of the discovery, right? If you follow your passion, your paper will be so much better.
I just wish I had more time. The deadline is coming up soon.
I definitely wouldn't want you to be late handing in your assignment, but I'm all for your writing a paper on the Harappan writing system when I contact the archaeology department. I'm certain that they're up to date with the research. I'll pass on anything they can give me. If the department chairman is free, I could even arrange for you to meet with him and get his insights on the topic.
Okay, thanks. I'll have to think about it, though. I feel like I might be on a wild goose chase, and I'm not sure I have time for that. I'll look into it and let you know what happens before the end of the week. Now get ready to answer the questions. You may use your notes to help you answer. 1. What is the student's main problem? Two, what does the student say about the Harappan writing system? 3. According to the conversation, what aspects of Harappan architecture does the student want to consider in his paper? Listen again to part of the conversation, then answer the question.
Have you tried looking in anthropology journals? You might find articles that present the research in a more objective light.
I tried that already. That's where I found the conflicting research I mentioned earlier. I think it may be a lost cause.
I wouldn't go that far. Research doesn't always produce results right away. It's the thrill of the discovery, right? If you follow your passion, your paper will be so much better.
4. Why does the professor say this?
I wouldn't go that far.
Five. What does the professor offer to do for the student?
Test 6, Part 2, Passage 2. Listen to part of a talk on biology.
Okay, let's get started. Now, how many of you know the difference between a rabbit and a hare? Anybody?
Well, hares are, bigger, right?
Not exactly. Some species of hare are smaller than some rabbit species and vice versa. In general, hares have longer ears, larger hind feet, and longer legs than rabbits. This means that hares are particularly well suited for running and jumping. Now, another difference is that hares are born covered in fur and with their eyes open. This means that hares are much less dependent on their parents for survival than rabbits. Now, today we are going to look at one species of hare, the snowshoe hare. In particular, I want to discuss the various ways this mammal avoids predators. This is of particular interest because the species has such an extensive range. Here, look at this map of North America. The green section indicates the range of the snowshoe hare. As you can see, it covers the northern section of the United States and almost all of Canada. The size of its habitat means that this species has to deal with all kinds of predators. Okay, the snowshoe hare is most common in boreal forest ecosystems, the forests in the northernmost reaches of Canada. However, its range also includes mountainous areas where the forest is predominantly coniferous, as well as the deciduous forests of Alberta, Saskatchewan, and Manitoba. Basically, snowshoe hares are able to adapt to a variety of forest types. That being said, snowshoe hares do prefer areas with dense undergrowth because this cover helps to protect them from predators and provides them with food. The home territory of a snowshoe hare is approximately 8 hectares, 80,000 square meters. Now, the interesting thing is that within that area, the hare will create an intricate network of interconnected trails. These allow the hare to easily move between feeding and resting places. Major trails seldom change. Snowshoe hares follow the same routes in summer and in winter. They maintain these trails by clipping off stems and leaves that begin to block the pathways. Now, despite all the maintenance efforts by the snowshoe, these are not private pathways. Other species also make use of them. But the point is that a snowshoe hare will always know where it is at any time, and will always have access to several escape routes. Predator avoidance is also facilitated by the fact that snowshoe hares are nocturnal. That is, they are most active in the night. They can easily find food and move around in the dark. During the daytime, the snowshoe hare rests quietly in sheltered spots. It will sleep sporadically and groom itself. However, it is always alert. Now, I know what you're thinking. What about predators that hunt at night, like owls? Well, these are also a problem for the snowshoe hare. When confronted with a predator, the hare will usually use its great speed to escape into the underbrush. However, if the snowshoe hare is trapped in the open, it will freeze and rely on its natural camouflage to keep hidden. Of course, many species make use of protective coloration to blend in with the surrounding landscape, but what makes the snowshoe hare special is that the color of its fur actually changes with the seasons. The seasonal molt, which is the term used for the time when the coat of the snowshoe hare changes, is triggered by the lengthening or shortening of the period of daylight. During the summer, the fur of the snowshoe hare is a mottled brown. This allows it to easily hide in the dry underbrush of the forest. Once the amount of daylight begins to decline in the fall, the hare will grow a white-tipped winter coat. This is patchy at first, which provides excellent camouflage during the period when the ground is, only, partially covered by snow. By the time winter arrives and the ground is blanketed with snow, the hare will have turned completely white. This process repeats itself in the spring when the hare sheds its white fur and begins to grow its summer coat. Now, while this seasonal variation in color is an effective means of protection, the fact that it is related to the amount of sunlight may sometimes cause a problem. If the snow comes late in the fall or remains on the ground late into the spring, the hare is at a disadvantage. Can anyone guess why?
I know. Its fur will still change color, so it would be really, visible during this time.
Exactly. It molts regardless of the amount of snow. When this occurs, the snowshoe hare tries to make itself less conspicuous by remaining inactive. It will move around as little as possible. Just enough to get the food it requires for survival. Once its coat matches the surrounding terrain, it will resume its normal activities. Now, while the snowshoe hare is usually able to maintain a stable population using these methods to avoid predation, scientists have long noted that the size of the snowshoe hare population in North America rises and falls in a distinctive pattern. Approximately every 10 years, the population of the species rises dramatically, and at the peak of this cyclic increase, there can be as many as 500 to 600 hares per square kilometer. This is likely related to the availability of the shrubs and plants the snowshoe hare feeds on. Well, these fluctuations have been observed for over 200 years now by the Hudson Bay Company, early fur traders who came to North America from Europe. The traders recorded the number of pelts they had collected every year since the late 1700s, and they noted that there were cyclical rises and falls in the snowshoe hare population. Actually, even the Native Americans noticed this cycle before the Europeans came to America for the fur.
Ready to answer the questions. You may use your notes to help you answer. 6. What is the main topic of the lecture? Seven. According to the professor, why do snowshoe hares prefer areas with thick undergrowth? 8. According to the professor, what causes the snowshoe hare's fur to change colors? Listen again to a part of the lecture, then answer the question.
Basically, snowshoe hares are able to adapt to a variety of forest types. That being said, snowshoe hares do prefer areas with dense undergrowth because this cover helps to protect them from predators and provides them with food.
9. Why does the professor say this?
That being said,
Ten. What can be inferred about the snowshoe hare population? (11) Why does the professor mention early fur traders?
Test 6, Part 2, Passage 3. Listen to part of a talk in an astronomy class. I'm willing to bet at some point in your childhood you heard Goldilocks and the Three Bears, right? You know the fairy tale. A little girl named Goldilocks is walking in the forest and happens upon some bear's house. She goes inside, sits at their table, eats their porridge, then sleeps in their beds. You know where this is going.
Yeah, each time she says something like, this bed is too big, and this one is too small, but this one is just right. Or, too hot and too cold for the porridge.
Right. Well, there's a concept in astronomy called a Goldilocks Planet, and that's what I'd like to discuss during my lecture today. Goldilocks planets are a subset of planets that meet a certain set of conditions, like the ones you just brought up, making them likely places for life to be found. Let me restate that. If life is ever found on other planets, it will likely be found on a Goldilocks planet. So, why do you think they call them that?
Let me guess. Since we call them Goldilocks planets, the planets that would host life can't be too hot or too cold or too big or too small, right?
Exactly. There are 5 different properties astronomers agree upon when it comes to the planets that are best suited to hosting life. The first one I'd like to talk about is distance from the parent star. How far is Earth from the Sun?
147 million kilometers, give or take.
Good. That distance between Earth and the Sun is called an astronomical unit, or AU. And for a planet to be habitable, If the star it orbits resembles the sun in terms of brightness, the planet has to be between 0.7 to 3 AUs away from its sun. The trick is that the planet has to have the right temperature to have liquid water. That's essential to hosting life. And a planet's temperature is a function of the distance it is from its sun. This region is called the solar system's habitable zone.
You just mentioned brightness when you were talking about how big our solar system's habitable zone is. Does brightness play a role?
Oh, it certainly does. The brighter a star, the farther away the habitable zone is going to be. So, think about what would happen if, maybe I should say when, because it'll happen a few billion years from now, when the sun becomes a red giant. In this stage, after it runs out of hydrogen as fuel, it will blow up to hundreds of times its current size and appear at least 1,000 times brighter. The increase in brightness would shift the habitable zone to an area of 4 AUs to 20 AUs from the sun. You can see the effect brightness has. Now, what's a third factor you can think of that would affect how habitable a planet is, whether or not it's a Goldilocks planet? Yes, Michelle.
Well, what about the orbit of the planet itself? Like Mercury. It has a pretty elliptical orbit, so the temperature could fluctuate a lot between when it is closest to the sun and when it is farthest.
You're absolutely right. Goldilocks planets would have orbits much like ours, more circular. The orbit would also have to be flat. There couldn't be a lot of wobbling or anything of that sort. In any of these cases, conditions would be too inconsistent to sustain life. Another thing, planets also have to have a certain mass. The accepted limitation on this is that the planet's mass be somewhere between 1 and 10 times that of Earth. Now let me explain why. It all goes back to the idea of liquid water. In order for a planet to develop liquid water, it has to have hydrogen in its atmosphere at some point. A planet's gravity helps to hold in hydrogen. If the gravity is too low, the hydrogen won't stay within the atmosphere and will go out into space. And as you're aware, gravity is determined by mass. If planets are much smaller than Earth, they won't trap any hydrogen. And if they're more than 10 times the size of Earth, they'll hold in too much hydrogen. And advanced life cannot thrive in an environment that's hydrogen-rich. There's a final consideration, and that's the age of the planet. Life has been present on Earth for somewhere between 3 and 4 billion years, and Earth is approximately 4 to 5 billion years old. That means there was a period of around 1 billion years before life formed. A similar period, if not a longer one, would be needed for life, particularly complex life, to develop. It can't just appear out of nowhere.
Professor, how many of these planets have been found? Are there any of them out there? Is this just a theory?
Well, we've got some powerful telescopes dedicated to finding such planets. There's the Kepler Space Telescope, for instance, and that's found a few Goldilocks planets thus far, and it's a near certainty it'll find more. Estimates put the number of such planets in our galaxy alone at around 500 million. So, if you're one of the people who believe there's extraterrestrial life, that statistic helps bolster your argument. With that many planets that could have similar conditions to the ones found on Earth, the chances are pretty good that we aren't alone in the universe. Now get ready to answer the questions. You may use your notes to help you answer. 12. What is the lecture mainly about? Listen again to part of the lecture, then answer the question. I'm willing to bet at some point in your childhood you heard Goldilocks and the Three Bears, right? You know the fairy tale. A little girl named Goldilocks is walking in the forest and happens upon some bear's house. She goes inside, sits at their table, eats their porridge, then sleeps in their beds. You know where this is going. 13. Why does the professor say this? You know where this is going. "14. What happens when a star becomes a red giant? "15. Why does the student mention Mercury? "16. What role does gravity play in making a planet hospitable? "17. What is the professor's attitude towards extraterrestrial life?